First, assuming that you already have the Arduino library installed on your PC, from the previous session, if you want to use the Pixy2 library, you need to include it and declare that you will use the Pixy2 library as shown. Next, for Pixy2, you control Pixy2 using an object called Pixy2. So, you input Pixy2 and the variable name to control it. And the most representative command is called getBlocks, which is a command to retrieve the object information recognized by Pixy2. After typing the getBlocks command, process the objects, simple, passing in stone, from PC, mesh, PC, point, PCS, point, C, color sol, this PC, point, PC, point, PC, point, PC, point, PC.emd, yarpc.e, PC.m. The bunch PC.gems, ccc.blocks are in an array format containing information about each recognized object. Additionally, pc.ccc.num.blocks indicates the number of recognized objects. If this value is 0, there is no need to proceed with the next task. Next, let's take a look at the attributes of the blocks. There is an M signature, which is the signature I have. Previously referred to as the mode, the recognized object here is referred to as I, but it could be 0, or it could be 0 up to the number of objects, or it could be 9 with an index being used. This is the mode of the recognized specific I index. We mentioned that there are a total of 7 types. This information tells us which mode and which signature it is among the 7 types. Next, mx is the x-coordinate of the recognized object, which is the central coordinate. From the center of mass, the x-coordinate at this location ranges from 0. There can be up to 316, and then m_y, which is the y-coordinate of the recognized object, so it can be recognized from 0 to 208, and then m_width, the width of the recognized object, from 1 to 316, and m_height, this is the height of the object, which can be recognized from 1 to 208. Next, if you look here, you will see Pixy CCC blocks and m_angle. This is about when the recognized object is a color code. We have trained and stored the color code, but it is not always in the correct orientation. So, even if it was tilted or upside down, you can now assume and see the angle of the color code. As shown in the picture, the color code tells you the angle at which it is currently rotated, such as -88 degrees, -45 degrees. Next is the M index, which tells you the current index of the learned object. The M under the age indicates how many frames the recognized object has been detected in so far. The more frames it has been detected in, the more it has been recognized and exposed to the camera. This can be used for further judgment. This is not an attribute value, but a command. When you type jump print, Arduino will output information about the object, including the previously mentioned details. Additionally, there are other commands such as set servers, which allows you to control servo motors, set brightness to adjust the brightness, and set LED to change the color of the RGB LED to your desired color. Let's just simply take a look at an example. This is the example we saw last time called CCC, hello world. In this example, we declared the library using shot, include, and Pixy2 declared variables related to Pixy2. Set the serial communication baud rate to 115200 and initially displayed starting on the serial monitor. Then we initialize the PC library with pc.init. In the loop function, we declared the pc_ccc I variable and used pc_ccc get blocks to command the retrieval of recognized object information. Then there is only none blocks, which can be 0. If it is 0, it is recognized as false, so it does not enter this for loop. However, if more than one object is recognized, it enters this for loop, prints detected, then displays the number of recognized objects with pc_cc none blocks, and then within the for loop it shows each block's index IMO using the print statement explained earlier in the process. This is done in the system and in the output respectively. Next, let's take a look at the example from the Pentit Servo Motor Kit E. Here as well, we declared the PC2 library, and for the PID loop, the company that made the PC2 has internally integrated a PID library to control the PC2 servo motor. Therefore, I won't go into detail about the PID here. So, we declare variables related to PC2, and also declare variables related to the PID loop here. As we saw last time, we have two declarations for controlling the pan motor, pan tilt motor, and tilt motor. Then, in the setup, we set the baud rate to 1150-200 with serial begin, and start by printing and initializing with Pixy_init to initialize the Pixy library. Next, we use Pixy change plug to handle color connected components, similar to how we select and change CCC color connected components in Pixymon from the menu. Here, we change the mode programmatically. The PC, so I changed it, and then if you look at the loop, I declared the variable I, declared J, then set a 64-byte buffer, and then declared int32 for pan offset and tilt offset, which are variables used to control the motor. I issued the pc.ccc.getBlocks command to retrieve, gather and collect information, and then used pc.ccc.numBlocks to check and verify the number of recognized objects. If it is 0, it won't enter this form, but if it goes into else, it initializes IDA and sets up the PID. Then, using PC set servers, it retrieves the values related to PID and sets the servo motor with set servers. If more than one object is recognized, it keeps incrementing I slightly and appropriately, and additionally, since I is in units of 60, and when I is divided by 60, the remainder is 0. It will be 0, 60, 120, 180, and so on. And it is set to output here in that order. And then, calculate the pen offset. Frame width is the total width, frame height is the total height, and PC is the recognized size. Divide the frame by that. You can consider that the motor's movement direction is calculated based on the MX coordinate of the first recognized object, the Y coordinate of the first recognized object, the total width, and the total height. Even if you don't quite understand this part, you can just skip it. Next, update the pen loop point and the pen tilt loop point to update the PID related stuff. You can also just ignore this. So now, after all the settings are done, when something is calculated in the PID, you control the servo motor through pc.setService, and since EF0 and NDEF are macro functions, they do not actually output. However, if you want to see how the actual calculations are done, you can change EF0 to 1 and it will be output. You can then see how the values are calculated based on the output. Roughly speaking, you can control the Pixy tool using the Arduino API like this. This time we looked at the Arduino API for Pixy2. Next time we will take a look at the Raspberry Pi API for Pixy2. See you next time.